Yeah, so last time we talked about model layering, bedrock. I'm giving a talk at 11:30, or I have to be there at 11:30 this morning. So I thought I'd run through what I was talking about with the Mahomet, talk about glacial layering. So I've added some things in there. So if you're not familiar with Illinois, I'll explain a little bit about Illinois, but Illinois is covered with glacial deposits. There's glacial deposits all over the world, Russia, China, all glacial deposits, Europe. And the reason we study them so much is because they're heavily used. So the hydraulic conductivity of the sandstone is maybe 2 feet per day. Glacial sands are 300, 400, and on up. So huge difference. So you can get 3,000 gallons a minute out of a well, or about 5 million gallons a day. If the only reason we get 1 million gallons a day out of the bedrock wells in Northeast Illinois is because they're so deep. You know, there's a lot of available drawdown. But, you know, these wells will produce the same amount of water with 20 feet of drawdown that the wells in Chicago are making with 200 feet of drawdown. So it's a huge difference. And so when the water supplies in the state were developed, you always went to the glacial deposits first if they were there, because they're shallow and plentiful water. If you had some, the world is not fair, and glacial sands are very hit or miss. Even places like Green River Lowlands, you might be surprised at how variable it is. So anyways, this picture, it's just kind of, it's hard to see in that. I need to change up the brightness on this. This is a sand boil. And if you don't know what a sand boil is, it's, you know, where hydraulic pressure is basically suspended all the sand. There's so much groundwater coming out. And this is where a little creek cuts down into the Mahomet. It's where, like, the first exposure, shall we say, of the Mahomet aquifer sand as you go west from Champaign. So there's under a lot of hydraulic pressure there. The river cuts down and we get these sand boils, and we almost lost Kevin into a sand boil once. But he fell in 3 feet into one. Wow. And yeah, so I was like, well, kind of lucky we didn't lose him. Depends on your point of view. A skinny guy like you or Willad or whoever, we would have lost.
What more point are we talking about, George?
Are you saying Kevin is dense? So some of these slides won't exactly pertain to what we're talking about, but if I get them to work. Did anybody go on the Mason County field trip? No, you did. So this is what the sand actually looks like. This is over in a nature preserve in Mason County, where we actually have sand dunes, and you can get the nice sand dune shapes and stuff. Most of them have been vegetated. This is kind of on the top of a hill where you have a lot more wind, and the vegetation hadn't been able to be established. So you can see there's some cactus. It's hard to see, but there's cactus in there and all kinds of things that you'd expect in a sand dune, just not in Illinois.
Right.
So what is, well, we'll talk about what it is, but first we'll show where it is. And this is a map from the sole source aquifer thing, which we can talk about all the politics later. But it's basically outlined in yellow. So we're here in Champaign-Urbana. It goes over to the state line, which isn't quite shown well on here, but and all the way, the western edge is the Illinois River, both in Mason County, which we'll talk quite a bit about, and in Peoria. Yeah.
George is a child. Young George.
Yep. Child labor. Hey, he looks a little older than a kid. This is one of the first wells in Urbana. These are actually glassed wells. But, I love the steam engine that they used to drill a well. You know, and these wells took a long time to make. Moving on, this is also an old picture from Champaign-Urbana. This is used to be when the Boneyard Creek was covered over by engineering buildings, and one of them, the university used to have its own water supply, and so there was a bunch of wells and a water treatment plant where Granger Library is now. And so this is just a Aquifer test from that. Moving on to Champaign-Urbana, this is, if you've all seen this over by outside the Illinois room, this is our electric analog model of that Tom Prickett put together. He didn't do all the soldering, but this is Champaign-Urbana, and you can see the outline of the Mahomet Aquifer going through there. So that was our first attempt to model the Mahomet in Champaign. Yeah, I can kind of skip over some of these things, but you know, what do we know? What can we learn? Obviously, the aquifer geometry and extent, we need to know a lot more about that, and that's some of the discussion of doing geophysical stuff. Aquifer flow and recharge. Yeah, this is more for my audience later. So,
George, how did you make that animation there at the bottom?
that is in visual MODFLOW. Yeah, you can do things like that in visual MODFLOW.
Okay.
And
that's pretty fancy. I like that.
Yeah, it is. It is. And that was done, no, more than 10 years ago. No, 20 years ago. It was done,
MODFLOW is.
yeah, they beat all the good stuff out of it.
Yeah.
Yeah. Yeah, so you had more control over how to do that. So this is drawdown from when the Decatur well field kicks on. But yeah, I like those colors. This is before we added Mason County to the model.
Yeah.
Probably we did not have Mason County in the model at one point. Yeah, that's interesting. There's just some pictures of field data. I won't go into that, but you know, to understand the aquifer, obviously we need borehole data, but we need to do aquifer tests. We need to be out there when they're drilling to see what the heck they're going through. Water use data, water level data, aquifer tests, and then also two very important things for the Mahomet have been water quality and isotope data. Really helped out. Keith Hackley has done the isotope work. He was the ISGS, but he's also around town. He works for Isotech now. But you know, when you find you find tritium, modern carbon in the Mahomet Aquifer, it's a good indication you have water coming in somewhere. And then the construction of the model.
What was that picture in the lower right?
That's the aquifer test we did at Decatur. So that's
oh, okay. You just
dumping it into Sangamon. Yeah. So part of what I was talking about today is what we've learned in the last 25, 30 years. And so this is our observation well network for the Mahomet Aquifer. Do you know how many of these we had when I started the survey?
Only a handful.
Two. We had Petro North and Snycardi. Well, some of them went in right before, but
yeah.
This network was all developed in the early 90s from existing wells, but
that's in, what is that, West Mason County?
Yeah, this is Mason County, because all the water authorities came into being around 1990, and so Imperial Valley, one of the things they did is establish a monitoring network. So that was the early 90s. All these were drilled in 1990, 1998 or so, 1997.
Hmm.
These were all drilled in the 1990 when the new Decatur well field went in.
Which we still need to get those.
Yes.
We,
I have not heard back from them.
Okay.
I'll bug them. And then these were put in 1994, 1995, some in 2000, and then a bunch in 2008 and 2009. So, as well as 94 and some of the ones in the West. So, basically, we didn't have any Tazewells in the Mahomet. So, we didn't really know. We didn't have a good potentiometric surface map. We had a little potentiometric surface map for Champagne. And then we did mass measurements to kind of get this area in mid-90s. We did this area in the 90s. And this part had been done in the 60s. Mason County had been done in the 60s. And then again in 94. So everything was kind of done piecemeal in the Mahomet. So.
yeah, how do we get the boundary, mark the boundary of the subsurface aquifer? Like,
Yeah,
some shady areas?
I'll explain that. I'll explain that. Yeah. So obviously are greatly affected by glaciers. So that's a nice picture from West Antarctica. But you can imagine a mile of ice plowing everything, carving out the Great Lakes and dumping it all over Illinois. So Champaign-Urbana has been compared to what the New River looks like in West Virginia. It's a little steep, I think, but it's meandering but it is a drainage way, so it should have a continuous flow through it. And the center of that valley is called a bow leg, the Bedrock Valley. So the first glaciers that came, I'm going to grossly simplify this because there is some till at the bottom, but basically produce a lot of outwash, and that outwash coming out of the sand or out of the glacier deposited the first sand in the thickest Mahomet Aquifer deposit, and so it formed these braided streams, the sediment choked streams. So there's so much sediment coming down that it's all falling out and forms these braided streams. And then when they retreated, they left a bunch of glacial till on the top. And so that outline of the aquifer essentially corresponds to this elevation. And so that's about 500 feet. So if you looked at the bedrock surface, this line here roughly corresponds to the 500 feet in elevation.
That's how you came up with it.
Initially, that's how it was done.
Yeah.
So, so it's just simply this elevation. Now, this elevation is extremely consistent, actually.
It is?
It's like between 500 and 520.
Oh, wow, okay.
When it stopped,
Yeah. That makes it really convenient, doesn't it?
And when you're pointing, and you just happen to be standing right in front of me, are you pointing to the contact between the sands and the overlying sediment? Yeah.
Yeah.
Okay.
So the contact right between the banner and the glass, where you're saying, is really consistent.
Well, no, this isn't the glassware. This is banner till.
Oh, okay. I'm sorry. That's right.
The top of the Mahomet sand itself.
That's right.
In the banner still.
Now there are other sands that cut down and have since eroded the Mahomet, top of the Mahomet. The top of the Mahomet, the top of the banner is an erosional surface. So, there's all sorts of erosional surfaces in here. So everything is kind of, and I'll get to that and how we kind of solve this problem. So this is the bedrock valleys. On the outwash plains, the rest of it, or on the uplands, bedrock uplands, we largely get till. So the glaciers are retreating, you know, and all the sediment is falling out. So you mostly get till, which is a combination of sand, silt, gravel, and like just garbage, geologic garbage of whatever's in the glacier that falls out. And then there's little smaller sands with it. So there wasn't the big river system that it was filling up with the sands. So, you know, throughout Illinois, that's not over the Mahomet or even the shallower deposits over the Mahomet, you get thin sands within the tills. And that's because, you know, the ground got leveled out pretty much, and the glaciers just kind of more evenly retreated and melted in place, and all the shit fell out.
Which glacial bands we're talking about? Just the Illinois or the Wisconsin?
This would be all three.
Oh, okay.
Yeah, so there's little sand stringers in the upper banner.
What do you mean? So pre-Illinois and then for the initial stuff, the very bottom of the valley?
Well, this would be like the rest of Champaign that isn't either, I'm sorry, it's for what's ever over most of Illinois and after the Mahomet was filled. So like the Glassford and the Wisconsin are like this. Yeah, where it's mostly till, but with some outwash stringers. Glassford never gets very thick in Illinois, maybe 50 feet in rare occasions.
Yeah.
Whereas the Mahomet sand is routinely up to 150 feet thick.
Yeah.
Because it's filling in the deep part of the valley.
Right.
There was more relief, there was more motion to carry away the fines and leave the sands. So if you look at the Gulf Coast, you know, Mississippi Delta, just a lot of really fine sediment that all got washed down there. That's where all the fines. So the Mahomet Aquifer, this is a map of the old Ohio River or the Taze system. So the glaciers came in, of course the water couldn't drain up this way anymore. There's a large lake down in West Virginia, but then the Ohio switched to its new course. Likewise, at some point the Mississippi moved, and it used to come through the Green River lowlands here, and then follow the Illinois River down to Peoria would be here, and then make its way.
Somewhere in McLean County then, where that old.
Yes, it's Tazewell County actually, where they come together. So that's why the Mississippi looks quite a bit different in this stretch, and like why it has high bluffs and rock outcrops in some places. So if we look at the thickness of the glacial deposits, the Mahomet really sticks out because it had that whole valley to fill in, the Green River lowlands stick out, and that's extending up into the Rock River Valley and the Pawpaw. South of the Mahomet, basically not much. You know, if you're looking at glacial deposits, you're looking at sands that are in more of these modern river valleys on the Kaskaskia and the Emperor, and they're not very extensive. They're confined to fairly small bedrock valleys. And so Lake County, of course, has quite a bit. There's a lot of marine activity up in Lake County. And the deposits get very thick, and then it gets a lot more complicated as you go into Wisconsin. So south of the Mahomet Aquifer and western Illinois, I don't know if there's many public water supply wells and glacial deposits at all. It's just not really. And then as you go north, there's this big empty area where there isn't any wells that are on glacial deposits. So it's the middle Illinois Valley, the Mahomet, the Green River lowlands, and then a bunch of things. Northeast Illinois, yeah. So it gets over 500 feet.
Yeah,
right around the Amboy.
We saw Bedrock over that.
We saw Bedrock, yeah. South of the Amboy, sorry. There's a cliff in there somewhere. So you can see how generalized this is. There's this little stringer through here, which wasn't really discovered until the early 90s. And Steve had a lot to do with that. But you can kind of see how simple that was. So Bloomington wanted to put in a water supply out here, and also normal. Normal is the villain in this whole story. This is a little side note because they put in a well field in the Mahomet, and they screened their wells and 2 aquifers. And I don't know, I think there was miscommunication between the city and the drillers and whatever. But a whole bunch of private wells went dry, and the city said, well, our well's in the Mahomet, so it's not us. But one of their wells was in fact in the shallow sands.
It was over the glass.
Yeah.
Right.
And because of that, and all the private wells that went dry, the enabling legislation for the water authorities was passed. So all the water authorities, which are this government agency, local government agency that we deal with quite a bit, those all sprung up because of normal.
So when did that have was that the early 90s?
That was 82, sorry.
Oh, that.
That was in the 80s. And so when Bloomington
You know how
wanted
many
to-
wells went dry?
No. I know Adrian Visocky wrote a report on it, so there was a report
Oh, okay.
somewhere on there.
Somewhere in there. It's this one.
No, it's older than that.
That would have been amazing.
You can't fool me.
That would have been amazing.
You can't fool me with that. If I look long enough, I can figure out which one it is. It'd be on that lower shelf under the orange reports.
That one.
Oh, it's this one.
Yeah, could be. Yeah,
Yeah,
that's it.
right, that's it.
That's it.
Oh, boy.
Nice job. Dave.
Assessment of aquifer conditions west of Normal, Illinois, yeah. 1982.
1982, yeah.
There we go.
Wow, Dan. Go to Vegas real quick.
Yeah.
Well, there's 30 copies of it right there.
Yeah. Every one of them. It's normal report.
Yeah, this whole shelf is.
Yeah, so Bloomington also wanted to go to the Mahomet, but there was such bad public opinion because of the normal thing that they kind of formed this coalition with the water authorities and the whole steering committee, and Steve was a principal ringleader to all of that. And that's when they drilled out what we call the Tazewells, which are all these wells.
The orangish.
So normal had 2 odd wells. That was about it. There was actually nothing else out there. Bloomington normal are. This is normal. This is Bloomington. Bloomington's water supply is some lakes up here, and they want to go off surface water. And we can discuss that further at a different time. So this is what happened. So they drilled all these wells, and the aquifer map went from something that was fairly simple and straightforward to something that was extremely complicated.
Yeah.
So the main channel is kind of coming through here, and maybe it goes this way, or maybe it goes this way. This would be the ancestral Mississippi coming down here. Peoria's over here, so it's better.
Is that why it's deeper, you think, or the thicknesses are greater in those sections?
Yeah.
It's the ancestral Mississippi.
Yeah, but where the Mahomet comes in was a big question. So these white areas are where there's basically no Mahomet. It's like very unnerving to drill into it and find bedrock much higher than you thought.
So
That's
so that's what I was going to ask. Is it because that's of thickness of the Mahomet sand, but is that because it's a bedrock high, or because it's
Yeah, these are
banner-
bedrock highs.
Okay,
So the top of the Mahomet is fairly flat.
okay,
Yeah.
I see.
Yeah.
Okay, so those are bedrock.
Yeah.
So
and
we're
That's
just,
how the river channel
Yeah.
underneath undulates, right?
Yeah, I just wanted to clarify that it was a bedrock height and not just the banner is still the same thickness,
Yeah.
but instead of it being sand till, it's just a pocket of deep till.
yeah.
I just wanted
Yeah, no, that's a
Clarify.
Yeah,
Yeah.
good point.
So a little side story. So we did not have anything in this area. So we didn't know whether this went up this way or over this way. And there was this data point and data point here. And I was like, well, okay, is the aquifer there or not? You know, because it would make a big difference if this high went all the way out here or if it was.
Yeah.
And so we managed to get some extra funding and GS drilled a well. And it turns out they were right, and there was 100 feet of sand. So I had to eat some crow, but I mean, it's still good to verify
Yeah.
that. So you can ask Dave Larson about that.
Sounds like they need some
But
HTM out there.
I don't know how much that would help, but you definitely can't be afraid to be wrong.
Yeah.
In this. All right. So 3 basic glacial advances, and these names are what we call them in Illinois. Other states call them different things.
Yeah, so, okay, that's what, so banner is pre-Illinois.
Yes.
Okay.
All
All right.
And so I have the main formations are the Banner and the Mahomet Sand. So that's 500,000 years old. Then the Glasser Formation is newer. So the pre-Illinoian is largely only found in the bedrock valleys. If you go north or south, you basically don't find any pre-Illinoian. And so this was kind of, they call it pre-Illinoian because it was kind of discovered after the Illinoian was mapped. So you see some of these names like Glassford, Henry, Wedren, they're all towns over by Peoria.
Yeah.
And then the Mahomet wasn't really discovered until they started drilling into it in the village of Mahomet. And so, yeah, so this first episode is what we find in the bedrock valleys, Banner Sand. Then you'll see some of these other names, the Harmat and the Hillary, the Tilton. They're all different, like advances, and I kind of ignore the names.
Yeah.
There's a sand, there's a till. That's all I care about.
Much to the dismay of the ISGS.
Yeah. And so, but when you drill through this stuff, you're getting sand, 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 sand. Then you might get silt, and might get a thicker sand. And it's really impossible to map. Okay, well, I got this little sand over here, this little sand over here. So what Dave Larson at the ISGS did was decide, okay, this is not working. So what he decided to do was to find all the old soil layers and map those, and then map the different, the Illinoisan is one unit and Wisconsin is one unit.
Yeah.
And so,
It was more of a.
and the only way to do that is to find those soils. So in between 400,000 years ago and 130,000 years ago, there was erosion. So you had a lot of cutting and stuff going on, but then you also had the soil formed. And so if you can find the soil, then, there's a difference. So oftentimes it'll be, you look at a log, it'll say peat, or it'll say actual log, not a well log, but, things like that.
A wood log.
And then in the Sangamon soil is the top of the Illinoisan. I mean, it's very common to hit logs and peat, and we hit some out at Decatur when we drilled out there. Which reminds me, I don't think those Decatur outfalls are in the network. I'll have to check on that. Better write that on the board.
Wait, what?
Oh, the wells we put in for the Aquifer test at Decatur. We did an Aquifer test over there.
I'll write that down.
Yeah.
It is also recorded.
Yeah,
So-
but we'll see it here written.
Yeah, no, I agree. Just making it.
So to start making sense of all this in a modeling context, we needed to start mapping the soils and kind of distinguishing, you know, what's a Glassford sand, what's a Wisconsin sand. There's very little Wisconsin sand except for the most recent Henry formation. And so you've been to Henry.
Yeah, I have, nice town,
Nice town.
interesting people.
Interesting. Oh yeah, we went to Henry and there's a carnival going on. Oh boy.
Just the locals at the park.
Just a little- heard some new words. Yeah. Anyways, so the Glassford is the one they call it the Illinoisan because it covered almost all the way to southern Illinois. And I don't have a glacial map here. Glacial map. Didn't find this. It's a little hard to read, but yeah. So this is a Bedrock topography map. So if you look, this is the Mahomet coming through. It's really hard to see. But you see the rock and the pawpaw,
yeah.
the green river lowland, Detroit, and the ancient Mississippi coming down through here. This is a very bedrock surface. So what it shows you is these gray areas weren't glaciated. So the Illinois glaciation came all the way down to here. And the Wisconsin only covered half the state. Yeah. So south of here is all older stuff. And it's a lot more clay rich. Wisconsin was a little more sandier. So at some point we talked about how the hydrology is a lot different south.
Is this the line for the Illinoisan or the pre-Illinoisan?
This is the Illinois.
Okay. Is
Yeah.
the pre-Illinoisan?
It's not that.
Okay.
The pre-Illinois was not as far.
Right.
The
We
Illinois
only
was
find
the
it-
furthest extent south that the
Yeah.
glacial advance.
So this is a map of the bedrock valleys, as they call them now. So the rock and the Troy lead to the pawpaw, which go into the green river lowlands. Here's the Mahomet coming through here. So a lot of these, the Danvers Valley.
Tacoma. Never seen
Yeah.
that one.
So you'll see a lot of these names referred to. The Kaskaskia, of course, is also the location of the Modern Valley. For the most part, there are some exceptions where Modern Valley is.
So is the rock, more or less.
Except, yeah, but the rock,
But
actual river comes off and
except-
takes off here.
yeah, when it diverges like here and it goes this way.
So there's, yeah, so glaciers screw everything up.
Yeah, really complicated things.
Leave that out.
Oh.
Thanks.
Yeah, I'm surprised I don't have a glacier. That was really.
That's why there's really cool topography in Northwest Illinois.
Yeah,
I was small one, I
I've been
don't
reading
know.
about that.
Never.
You have a small one?
Yeah.
Yeah, okay, that'd be great.
The Driftless region, yeah,
Yeah.
it's really beautiful.
Yeah, I've been reading about it.
Yeah, it's really weird why it's like a little island. I mean, it goes into
yeah,
Wisconsin and
yeah.
it goes into northeast Iowa. and it's just this little island that was never,
Yeah.
because like there's a couple lobes that came down and met, but they didn't
Oh,
fill in.
glad I have it.
Weird.
Go get them.
Yeah, oh, I need to steal this colorized version for my slide. Well, there's a lot of disagreements over the GS. What is what? Oh my gosh, don't even get him started. Okay. That's why Jason is so nice to work with, because he's not
He doesn't
caught
really
up in
care.
all the things, but,
Despite being a glacial geologist.
yeah. So the Illinoisan covered almost the whole state except for the southern tip of the driftless area and that little sliver.
Weird.
And so this till is a lot more clay rich. So the streams are a lot flashier. Sorry.
Oh wait, the Illinoisan is more clay rich than the Wisconsin.
Than Wisconsin.
Oh, okay.
And so, yeah, so.
There's less thickness than Illinois.
Oh.
Oh, for that Illinois.
Yeah, that's a nice one.
Oh, it's a little bigger than.
And so, oh, this is, yeah, this got the lakes on it. Okay. Yeah, this is actually better. So, the yellow is the outwash, it's out the surface. So, the Mahomet, there's a couple of sands that are involved, but the pre-Illinoisan that you don't see exposed to the surface anywhere has all been covered over by the Glasper that's part of the Illinoisan. And then the Wisconsin came in last, but it only covered this part of the state. So if you drive south from Champaign or if you drive over to Mason County, you actually go down a hill.
Big hill in Illinois.
Big hill. Yeah, you're like,
Takes your gear down.
yeah. Yeah. By Pennsylvania or Texas. But you can actually see the difference. And actually it has a very economic, that little hill in Illinois is where Lake Shelbyville, Lake Decatur, Clinton Lake, and Peoria Lake are all lined up on that. Because the only place where they had enough relief to make those lakes.
Also a lot of.
That's all these retreating moraines.
Yeah,
Yeah,
so,
yeah. These are all like several advances, but this is the maximum extent. So come back, retreat, come back.
Right.
Yeah.
And that's the Wisconsin. or
This
Wisconsin.
green is all
Yeah.
Wisconsin.
now the Illinoisan doesn't have all those moraines. It's
Hmm.
just a lot more flatter.
Yeah, I always wondered why there's so many, why you didn't see this pattern of marine development in the Illinois.
Yeah.
And if it was
I
just
don't
eroded,
know.
Yeah, I think it's a lot older, so they should
it's
have
just
all.
older and they should have just eroded down.
Yeah. I mean, my glacial geology professor said because the land was so flat, relatively flat to start with,
Oh.
because it's got flatter,
Yeah.
because there wasn't, it was just sheet runoff. And actually couldn't-
Oh.
And is this more directional because it was coming over where the Great Lakes were?
It's coming
It's
from
coming
the
this
Geary.
way.
Yeah, so it's preferentially gouging those sediments and then depositing them in the moraines.
Yes,
Okay.
yes. So the
And I guess that's the
original,
difference between the two episodes.
the original one came from Lake Michigan, and of course, Lake Michigan was all Devonian shale. I mean, it was land before the
Mhm.
glaciers came.
Mhm.
And the glaciers carved all that very weak shale out and deposited that as the Illinois till.
Okay.
Then the Wisconsin picked up a lot more stuff and different stuff as it came from the east. So it was riding over dolomites and other things.
Hmm.
I don't know, you'd have to talk to a glacial geologists.
No, that's interesting.
The other interesting thing here is, okay, so these blue areas were glacial lakes. So, there was a lot of internal drainage, like in Champaign even here, where things got dammed up. And so where you have these lake clays, a lot of odd things happen. Like if you drive up 57 between here and Chicago, it looks as flat as a pancake. But then you have flowing artesian wells, and you can see for miles and miles and miles and miles that there's just flat.
No topography at all.
And you're like, well, that can't happen. You need topography to have flowing wells. But this lake clay is so dense that it's basically like the permeability of plastic. You know, it
Just, yeah.
it doesn't let any water in or out, which is why they have flowing wells in very odd places.
Because that pressure just has no way to get out.
Yeah, it just has no way to get out. Yeah, which is kind of interesting. I dealt with a bridge failure where they were building a new bridge and they pulled the pilings out, and the sand heaved from underneath, and they had this giant sand boil with sand coming up because they pulled the piling out. Wow. So
what's up with this?
those are more lights down there.
But they have them as Wisconsin.
they're colored that way.
Because
That's just outwash lakes.
because the sand that was getting washed down the river valleys blocked up the drainage. So in the Mahomet
Oh,
Aquifer,
but these aren't.
But they're not deposited
They're not-
from.
Okay, they're not technically.
yeah.
It lies a little bit different in the 70s.
So the
Yeah,
the
okay.
Mahomet Aquifer is coming this way, and the sand is getting deposited, and it backed up the Sodom Valley and the Middletown Valley, and so these silted up. So there's no sand in these,
Yeah.
but there's sands in the ones that come from the north.
I get why you'd mark that as a Wisconsin deposit though, because it happened in that time period, right? But it is. That's interesting.
Yeah.
And
Yeah.
then, yeah. Then the
But it's sort of a
whole
byproduct of it.
right. Then the whole state was covered with lust.
Hold on, what happened in Joe Davies County? You skipped that part of the story.
I know. That's subject to debate.
What is subject to
No.
debate?
I found a paper that tried to say that Joe Davies County wasn't, the driftless area is there because the limestone is permeable enough to take the meltwater through in the karst systems
Oh, wow.
Interesting.
so if you're taking away that meltwater, the
Yeah.
glacier didn't advance
Yeah.
because it got drained from underneath. So I don't know if I buy it, but I'll send that article around.
There's also
Yeah.
this really weird phenomenon in Joe Davies County. There's like these like ice caves where it's like some weird. It's these caves that are super cold all the time. It's like some remnant of. And there's all these different cave creatures in there because it's super cold. I don't know. I forget what the term was they're talking about here.
So to really piss off the glacial geologists, I boiled things down to something very basic. And to kind of conceptualize how, groundwater is flowing. So we have the Banner and the Mahomet Sand, the Glassford Formation, and the Wedren. We have a lot of these stringers, sand bodies in the Glassford. But we know that there's some internal plumbing of sand that gets water down.
Yeah.
So these could be erosional channels, because this was an erosional surface, and we know there's incised channels
Yeah.
that occurred in between the glaciers. Actually, on campus here, we actually have dry
There's dry Glassford, right?
Glassford wells, where you don't get enough recharge coming in to balance what gets drained out. So this is very low recharge. And then obviously when you get over to Mason County where the aquifers surface, you get extremely high recharge. So these creeks that are interconnected to some of the sands become extremely important to the story of what's going on. Yeah, who uses the aquifer? I'd like to show this picture because that's why they irrigate. This is during 2012. This is a 0 bushels per acre. That's 200 bushels an acre.
Yeah.
The cost of irrigating all together is probably 30 bushels an acre, not even that much.
So if you can get 200 bushels an
15
acre,
bushels.
it's definitely worth it.
Yeah, it's just not even, you do the math and it's
Yeah.
there. So this is one of the Champagne production wells. You guys have seen this, but the water supply wells in the state, you can see in southern Illinois how they're concentrated along the sands, the outwash sand, and you can see some differences quite a bit here. So the blue ones obviously are whether it's the glacial sands or thickness. I don't have.
What year is this?
That's as of 2012.
So
We'll have an update soon for you, Dan.
yeah, but you also see the glacial deposits reflected in the private wells. So where there's glacial sand, you have drilled wells, and so these red ones are all into the glacial sands. The yellow ones, which just look like a background on this, are all into bedrock. So obviously the Green River lowlands, or where you have these thick sand, you can even see the rock and the pawpaw
Yeah, I was
sticking
gonna
out.
say those really show up those Bedrock valleys.
Yeah, so this is just our database and what well is
Yeah,
completed
this is our 400,000 record.
Yeah, Devin
table.
did this. You see the American Bottoms, you see the Kaskaskia, you see Cache River down there where there's some sand from the Ohio River. But and then on the right you have the bored wells. So those are where you don't have water. You put in a well that's 3 feet in diameter and hope that you get water out of the clays, and it's enough to fill up this 3 foot wide, 50 foot deep, basically cement casing. It really gets by on storage. You can maybe have a gallon a minute going in, but if you store enough water, then you can take a shower or use a hose or whatever. So you can see those are virtually absent over the Mahomet, and then you get quite a cluster to the north, and of course almost all of southern Illinois. If they didn't have the thin deposits that are there, or go to the bedrock, they have the bored wells. So as a group, we really never worked south of the Mahomet much. There just isn't a whole lot, except in some isolated cases in Vandalia and through here in Metro East, obviously. But that's, in my experience, the only time that we really worked south of the Mahomet.
Why is that? Why do we not work south of the Mahomet?
Because the bedrock is all shale,
Yeah, Bedrock
doesn't
is
produce
productive,
anything,
and it's
and
mostly
glacial
glacial
clay.
tills,
So,
so also which don't produce anything.
so there really isn't
Really groundwater poor.
really groundwater poor, so they're not
Hmm.
developing water supplies out of it.
So and if you look at the purchase map and the
Mhm.
use map, it's all surface water use down there. Yeah. So
Yeah. So the
so much surface water.
rural water
wow,
districts
yeah.
have really taken off in
and so
southern
that,
Illinois.
and that map there shows surface water, which is why you see
It shows both.
it shows both.
This is
Yeah.
not a very good copy of it, but
Yeah, the orange is groundwater.
The orange is
blue.
groundwater.
So those
I
are
see.
like a lot of light blue dots down there. You
I
just
see.
can't really tell.
yeah, Ren Lake is here, Lake Carlisle is there, Mississippi River supplies all of that now. There's some other lakes. The northernmost, there's a few groundwater ones in Saline Valley and over by Lawrenceville, and then Champaign-Urbana. And this is for my audience at lunchtime, but I'm just showing you where they go.
Great.
Yeah, so who uses the aquifer? The red dots are all the public water supplies. I've highlighted normal in there. So I mentioned them specifically in the report as troublemakers. The Illinois American system here, this is a Decatur emergency well field. So they're only turned on once every few years when like Decatur gets low. And they're debating right now whether to keep them or not. Yeah, these pluses on here are from when we were doing an ethanol study and looking at the impacts of ethanol plants. This one was actually built, these other two were not. And then all the green dots are irrigation wells. So where the aquifers at the surface is pretty much defined by, you know, where these green dots are. But we also get a lot in Champaign, which we'll talk about, but those are more, a lot of those are for seed corn, but there is some poor soil up here that requires some irrigation.
George, if you go back that one slide, go back one more, or I'm sorry, a few more. Yeah, that one. You can see also in the blue triangle are the springs. You can see up in in Iroquois.
Oh yeah,
Yeah,
there's clusters.
the clusters of springs where those really tightly packed lake clays are.
Yeah, and they also, I think they also call flowing wells springs.
Yeah, that's
Oh,
the other.
okay.
Yeah, so those are the flowing wells.
Oh, no.
Yeah. Yeah, so right there.
Oh, okay.
Yeah, so we didn't really know the overall potentiometric surface of the Mahomet until 1998 when we published it in this report. So what I did was combine a bunch of things that were kind of all over the place. Birch had done part of it, Steve had done part of it, Andy Buck in the early 90s had done part of it. So this is kind of a hodgepodge of putting different potentiometric surfaces together and trying to get them to work. The student and I did that area. Then we had to make a few guesses. You know, because some areas we don't have any information on. You know, we've never done mass measurements because this is 4,000 square miles big.
It's a
So
large.
4,000 square miles for a glacial aquifer is incredibly huge. And when
Is it
things,
the largest like
I think it is,
continuous glacial aquifer? At least,
at least in the lower 48.
at least in Illinois or
Oh, yeah.
in the U.S.
Midwest, yeah. I don't know about Alaska, but probably nobody knows. But yeah, so this, I mean, we had bits here. We kind of knew, you know, we'd been keeping track of Champaign since the 50s, a little bit of it without any measurements. And some work had been done in Mason County in the 60s, and a little bit of work was done in Peoria in the 60s as well. But otherwise, we really didn't know what was going on. So groundwater flow is basically from west to east, or east to west. The high point is here in northwestern Champaign County and Ford County. That's where the glassford is at the surface. There's also a lot of quarries there. And then water is flowing up towards the Iroquois River, and this is where the flowing wells are. That water is trying to get out and can't get out. Flow down to Danville and the North Fork of the Vermilion there. The Kona Depression in Champaign, it's pulling water back. And then a very slow flow path. You see how greatly spaced these contours are? That's an extremely flat gradient.
Yeah.
Really slow. Like flat on a Monday morning. About as Mountain Dew and coffee.
That's you every morning with that coffee.
Yeah, exactly. Now, this is contradictory to what you would think. So the aquifer, as you get here, is starting to widen out and get bigger. What should happen in the gradient?
Should slow down.
Yeah,
It should
right.
slow down, but that's
Yeah.
not what it does. So it really starts to pick up there.
Do you think that's due to bedrock elevation? So you get a steeper incline and you gain.
No, I'll show you what it comes up to when I show you the model.
Okay, cool.
Well, so again, why that high recharge area? You said Glassford is at land surface there, so there's no wedging on top of it.
Right. The
And
middle fork is cut down into the
and so and then is the Glassford well connected then to the Mahomet sand then? Because there's that Banner Till.
Yes, and there, or near there is a connection, and that is one we know. Some of the connections we know from glacial deposits, and the other ones we infer. So a lot of the glacial geology we actually infer. And in this report, I included a bunch of hydrographs of paired wells that are from along this section of the aquifer. And so you can see that some of them behave in perfect unison, the Glassford and the Mahomet ones.
Yeah.
Others, like this one, they kind of behave similar, but there's no impact of the irrigation on the shallow well.
Yeah.
These two are in lockstep with the same elevation, which would mean there's a connection that's really close by. And it shows a lot of till in the well logs.
Yeah.
But the water levels are
they're essentially mirrored.
These are following almost the exact same trend, but there's 20 feet of head difference between the two. So that would probably indicate the connection is farther away.
Yeah.
Like this one, they're obviously in lockstep, but the connection isn't right there where the wells are. It's probably within a few miles of it. But the impacts of the irrigation are felt there. So all of these 4 well logs all show 100 feet of till.
Are the irrigation wells, are they screened in both aquifers, or do they
No.
stick to one?
Generally not, though. It's kind of there's exceptions because we've had problems because the irrigation wells in Champaign County, when they put them in, they didn't screen them in the upper unit, but they didn't grout that off. So they backfilled them with sand all the way up to so they created an artificial connection.
Okay.
And that's been a problem. So yeah, some of that could be going on too. That's a good point. I never thought of that with those. I'll think about that.
Go report on.
So this is our drawdown from 1930 to 2005. Obviously, Champagne's the biggie here, but there's drawdown over from Normal here and from Morton and East Peoria and some of the other towns up there. Notice there's been no long-term impact from the irrigation in Mason County. So this is just more for the benefit of the people at lunch today. Champaign-Urbana water supply. In case you don't know much about it, most of the wells, we are right there somewhere. The wells, the supply started off here in Urbana. There's some Glassford wells, and then after World War II, they went out to the Mahomet Aquifer northwest of town. So most of the wells are out here. And then in 2008, they also added the new Bradley Avenue well field. This is our Petro North observation well. It's been there since the 50s. There's some big industrial wells down here. And this well was put in to kind of look at the impact of one of the next, because they had no idea what the impact of those industrial wells would have on the city well. Those industrial wells dump water in the creek and send it by surface water down to Tuscola. And so, yeah, so that's kind of the how Champaign is set up. We have only 2 or 3, well, 1 big water tower, 2 big water towers now, and some standpipes around town. The flow rate for the water demand is they turn wells on and off to meet pumpage because they have so many and they all pump at different rates. So they just find a combination that works. The newer wells have variable speed pumps on it, so they can ramp up and ramp down water demand. So these are the ob wells in Champaign County. So they were all put in 95 and 96. Well, some would go back to 92. And then the second round that Illinois American paid for was all put in 07, 08, and 09. So the year that they were drilled is in the name. Different naming conventions, but and prior to these, we only had the Petro North and Petro South wells. So that was all we were using before to figure out what was going on. So we did a mass measurement back in, I forget what year, 09 or 05. Kevin went out and measured a bunch of private wells in addition to our ob wells, and we got a better idea of what the cone looked like. We also put a pentagon surface together for the 1920s. Looked at our old records.
Yeah, you had enough.
We had enough. We had about a dozen
Yeah.
pre-war
good.
water levels, and they were pretty consistent. Yeah, and then so you can use obviously that to make the drawdown curve. There's some very unusual things going on, which, well, we can talk about that in a bit. But when you see contours bunch up and spread out and bunch up and spread out, that means a lot of different things are going on. So here's a hydrograph from the Petro North well for 1953 on.
It's really nice to have long-term data sets.
Yes. So you can see this long-term decline. Where did I put the demand curve? Did I pass over the demand curve? Anyways, I'll rearrange where the demand curve is in the top. But, you know, basically the water level will respond with like 3 feet of drawdown for every 1 MGD. So if they produce another MGD, you get another 3 feet of drawdown. It's just basically a tight response for the most part. In 2009, the recession hit and they've stopped. Their demands really haven't gone up since then. And so we've been just, the Petro North has just remained pretty static. There's like, if this is Joliet, it just keep going down. But since Mahomet has a lot of recharge, and this noise you see are different wells kicking on and off in the well field.
So this is the difference between just the hand measurements
Yeah, this is the hand measurements.
and
Yeah,
then the transducer.
yeah. So what I'd like to do is put the hand measurements. Yeah, use the dash line.
Yeah.
Then I just added this morning. So these are some of the monitoring wells again, northwestern Champaign County. Here's Petro North, Petro South. I'll show you 95B here. And this just happens to be the Man-Love gas storage dome. So just throw it on there. And so
Oh, you just
For no reason.
For no reason.
Orientation.
So we had some really, really bizarre things happen to 3 of the wells, and this is one of them. So 95B is the Mahomet well. The GS went back in 08 and put in a Glassford well that was paired to it.
good thing you did.
It's a good thing they did, yeah. I should probably show the close up too, but Kevin thought the well was broken.
Yeah.
You know, but he still went out and measured it, and we discussed going out and fix it. Because the other one we think is broken too, but there's just no way to explain these high water levels. And it wasn't.
I mean, it shot up, yeah.
It wasn't until they
40, 50,
came back down to a normal level. And we went out, we developed the well, clean as a whistle. It all worked great. There was no problem with it. And we later found out about the natural gas leak. And so the leak was discovered somewhere in this time frame. December of 2016. And so that's when the leak was discovered. And the gas started showing up. So one of the wells at the Man Love Gas Storage Field corroded and got a bunch of methane into the Mahomet and started showing up in private wells.
So that's the
Which
well.
well are you
We
showing?
were driving
On
by,
next slide?
that's the well.
Okay.
Yeah.
But we also had problems here in
Right.
0809 and also in Dewey.
Well, that showed up in Dewey.
Yeah, it showed up in Dewey.
Do you have the hydrograph for that?
It's in my report. It's not on here. But Dewey is
That's far.
screwy because Dewey pumps gravel when we develop it.
Oh, that's
So we
right.
think the casing is broken, but we put a liner in it. We tried all sorts of
Yeah,
things.
That's right. I've been out there.
And this one just acted squirrely. So the transducer would be acting normal, then it kind of shoot, and then be fine, and then kind of bounce around.
So what happened with 98A?
98A.
Oh, that's a Mahomet well, so it didn't really probably show
Nothing.
up.
Yeah, nothing. So it was just these 3 wells.
Yeah.
So the gas is going to migrate up dip for whatever confining layer. So if the aquifer is
Yeah.
coming this way, and the Glassford channel might be coming this way, because it was only the shallow well here, and it was the deep wells there. Well, we only have a record for the deep well there.
And nothing happened. Nothing. You didn't see
Nothing there,
anything
nothing
in
there, nothing
08,
there.
08.
Yeah, no, nothing down there. Although we didn't have transducers on there, so we might have completely missed it.
Yeah. So the signature really showed up in 08, 09 and 96B.
Yeah, so that it also comes in the.
No.
So I'll show the blow off, I guess. I need to go soon, but yeah, so we could actually date that, and we know a better resolution on when the gas leak occurred, because it was only discovered because gas was bubbling out of the ground on a rainy day, and the guys happened to be there on a rainy day.
Looks like it started sometime in November.
Yeah, and the person who discovered it was a water survey employee, but we won't get into that situation. The former water survey employee, who kind of knew that something was not right.
Oh, I get it beforehand.
Yeah, so, but then the Attorney General's office can charge an extra $1,000 a day for every day that the leak was occurring. So if you look at the hydrographs for when the Dewey well started acting funny and the 08, 09 well started acting funny, they could charge the gas company basically like an extra $500,000. So here's a cone of depression at Champaign. I like to call that undersized, so it's not nearly as big as it should be. So if you take a TICE calculation and figure out how big this cone of depression should be, even if you have no boundary conditions, it's still going to be much deeper than what it is. If an infinite aquifer with the same transmissivity, just a confined TICE solution, is going to be much bigger than what we see. So like in Rantoul, we would have 50 feet of drawdown, but you see in this area we have none. We have none up here, and we have none in Monticello. So that's an indication that we're hitting some recharge boundaries here, and that's more than making up for the barrier boundaries that we were hitting. And so it's, this section of the Sangamon River has quite a bit of drawdown in it, so we don't think it's connected to the aquifer. But up here and down here, we definitely know there's some connection. Oh, here it is. So this is the pumping curve for Champaign-Urbana. So the east well, all the pumpage was from the east well field, which is the Glassford and Urbana. And then those have all been abandoned just recently, but they hardly ever use that after they switched to the Mahomet. So the red is the west well field, blue is the total. And then in 2008, 2009, they started using the Bradley Avenue. So we do see when they switched to using the Bradley Avenue well, obviously our monitoring well near that well field went down, and the one near the other well field went up. Not a big surprise. Here's a hydrograph from northern Champaign County. Very busy. I got 3 wells on here. This is all before the gas leak. And so this is all the hand measurement. You can see where we start to get the transducer data in there. And so we get these giant spikes occurring in the irrigation season. Yeah. And so, you know, we almost completely missed them in some years, but
Yeah.
08, 09, early 2010 were very wet years, so there wasn't much irrigation going on. And then 2012 was dry. And then because it was dry, a lot of irrigation systems went in, and so we almost had as much drawdown in 2013. But 2014 was really wet, and our growing season has been largely wet since then.
What about 2005 drought? They weren't irrigated?
I think
we
we
didn't
kind
measure
of
it?
missed that on the data, although that wasn't a bad drought down here.
Oh, it was up more up north.
That was more up north, yeah. So if we plot that out, so we took a bunch of measurements during the drought and kind of defined this, the drawdown that occurred between March and July. And that sticks out there for the irrigation district, also all these irrigation wells over in McLean. And then we don't see this mass drawdown. When the irrigation's going in Mason County, they're pumping 1 billion gallons a day. So they're using as much water as the city of Chicago is on a summer day.
You don't see much drawdown at
And we
all.
don't see any drawdown.
Is that because that irrigation water is eventually recharging back down? No.
No.
Right? That's just, we have that much supply.
We have that much supply.
That's
Yeah.
incredible.
So it'd be physically impossible to drain Mason County. You just couldn't do it. I mean, there's the Illinois River, the Sangamon, Mackinac, all coming in.
Which, again, so why is the gradient so steep?
Yeah. We haven't touched on that.
Oh, okay. I haven't touched on. There's lots of stuff. All right, why don't I skip ahead to that?
Yeah.
And I'll save the animation for later.
Plus, you probably need to go soon.
Yes, I do need to go soon. So here's the Mahomet model. And so this is just a 3D version of it. So this is a trick or the main part of getting the glacial data, the surfaces into the model. So here we have the dividing it up into units. And so, yeah, we could make a 27-layer model of this, but that's not really practical. So the Mahomet we kept by itself, but of course, you know, it has quite a bit of variation to it, but you know, to make it 1 layer, what the model really wants is capturing transitivity, so capturing the thickness. These sand layers occur, so we kind of divided them into 2, what we call the upper Banner, lower Glassford is 1 unit, and then the Glassford and the Wedren sands just weren't significant enough to worry about. So we had to lump those together to come up with a more manageable 6-layer model that you know, that wasn't so unyieldy and was mappable. So you know, these surfaces are fairly flat surfaces. They're erosional, but compared to everything else, they're fairly flat. And so Dave mapped those out and then assigned a lot of these other sands to either one of those 2 units. So we had a lot of surfaces for some of the model So the detailed areas were here that where Steve put in all those wells. This is a Champagne area that came much later in 08, 09, and is fully incorporated into the model. You know, we had some, yeah, we had the unpublished, yeah. We had some, you know, idea what was going on in Mason County. And back in the 60s, they had mapped the bedrock surface and the sand thickness. Some work had been done by Mark Anliker and some others, and the GS had done some work in Piatt and DeWitt counties. And then the USGS did a big mapping study of kind of this whole block with the ISGS. Dick Berg was involved. And so they basically divided it up into the same 7 layers that we used for this. So they took what we wanted. So they mapped this whole big area. So these are what goes into the Mahomet model. And so these all definitely do not agree with each other at the boundaries. So if you look at the Mahomet model, you'll see the resolution from some layers just exactly follows that line, you know, and so you go, what the hell's going on here? My bedrock surface looks completely different up here than it does down there, because whatever I had before was superseded by what was done for the newer map. Yeah, and so this area I just played God and guessed. So there really isn't any geologic mapping that's been done in Iroquois County. So I just put in 500 feet for the top of the Mahomet and called it good, and everything above it's inactive because it's not mapped. Similar, there was some work done in the Vermilion County area. So it's a real hodgepodge of stuff that's been married together. And when you look at the model, that's reflected in some of the surfaces. And some of that, so this is just some of the models that have been made of the Mahomet. So this is the one that I've worked on quite a bit, called the McTaz model. Gary Clark had done some modeling of Mason County. And then one of my students, Andrew Marsh, did Northern Vermilion County. And then Lane did a model for Decatur that it was very crude. It's just a 2D model that covered
Wayne Western?
yeah, when they used to have a group that was Lane Geoscience.
Oh, he's Humana. Okay.
Yeah, so you know, and so these were 2D. This was the first really 3D one. This was what you call quasi 3D, where you don't model the confining layers. You just say, okay, here's Aquifer A, Aquifer B, and you control how water is transferred in between them. We don't really use that anymore because it makes no sense in vertical profile. So this is a cross section of the Mahomet. So I've colored, I like to color them. The till's one color and sand's another color that try to make some sense, but these colors don't really make sense. But so this is going from Bloomington out into Mason County. So these are the surfaces that the GS mapped up to about here, and then I had to marry them with, well, actually I just created that on my own, but there was an unmapped area. Had to add those to the model. So this is genetically actually this is the Shelbyville moraine, so this is where the Wisconsin stop and the land surface drops. So it's kind of a step. There's actually glass through here at the surface, and then you get down in the lowlands. So yeah, so that's why, I mean, this looks like it's greatly exaggerated, but each of these cells is a quarter mile. Yeah, and a vertical exaggeration is 300 or, you know, so
Yeah.
We're not in Pennsylvania here, you know.
Greatly exaggerated.
So it's greatly exaggerated. Yeah, so the permeability values, this is in centimeters per second, but 300 feet per day and 0.00 whatever feet per day for the till, but there's about 6 orders of magnitude difference. And so,
And then are the light grades, are those glacier sands then?
yes.
Okay.
And so that really, for the glacial aquifers, it comes down to where there's holes in those clays. So if you look at these two till layers, every log will show that, very consistent. But we know water is getting through because we're pumping out of the Mahomet. There has to be water getting down there somehow. But if you just look at the flow budgets, if you have one of these windows, that's where all the water's coming through because of that 6 order of magnitude difference. And so when you're calibrating a glacial model, you can't be afraid to change the geology. So if you have hydrographs that you believe are showing there's good connection between the two aquifers,
You reflect that.
you have to reflect that. So if you go into the Champagne portion of the aquifer, there might be something this thick that I've changed to being a sand because I have to get water in. I know water's getting in. I know from my hydrographs that this glacier sand in Champaign County has the same heads as the Mahomet. So I know the two are in interconnection. In DeWitt County, these two sands can be 100 feet off in head. That tells me, okay, this clay layer is consistent and there isn't any interconnection. So
Yeah, I was gonna say.
that one stop and
The mystery of the gradient will be for another day.
Yeah, look, you'll see this is a recharge map. See, there's nothing up here, even though the Mahomet goes there, because it's not mapped. I don't have the shallow surfaces.
Well, thanks, George.
Thank you, George.
All right, and I need to run. I will see you guys later.
Do you have the copy on there? I just want to make. All right.